wherever you are in the world, whatever time it is. I'm so glad you made it here tonight. We're about to embark on a journey to the outer reaches of our solar system, following the trail of one of the most mysterious visitors our cosmic neighborhood has ever seen. A traveler that came from the depths of interstellar space, danced with our sun, and then vanished into the darkness, leaving behind more questions than answers. Tonight, we're unraveling the enigma of 3I/ATLAS. But before we dive into this cosmic mystery, feel free to comment your time and location below. There's something beautifully fitting about exploring the vastness of space while we're all scattered across our small planet, each of us under the same night sky that witnessed this extraordinary celestial event. The visuals are here for you, but there's absolutely no problem if you doze off midway through this cosmic tale. Feel free to close your eyes, breathe deep, and let your imagination drift through the solar system at the speed of wonder. If you find comfort in these gentle explorations of space and the mysteries that surround us, I'd be grateful if you'd consider subscribing and liking this video. It helps the algorithm find more curious minds like ours, souls who find peace in contemplating the infinite. Let's begin this journey to the edge of everything we thought we knew about visitors from beyond our solar system. You're an astronomer working the night shift at a remote observatory, surrounded by the quiet hum of sophisticated equipment and the vast darkness of space stretching endlessly above you. It's March 2019, and you're part of a global network of skywatchers, methodically cataloguing the movements of asteroids and comets that wander through our cosmic neighborhood. Most nights blend together in a routine of observation and data collection. Most objects you discover follow predictable paths, their orbits traced and calculated with mathematical precision. But then something appears in your telescope's field of view that doesn't belong, something that shouldn't exist according to everything we thought we knew about how objects behave in our solar system. A faint smudge of light moving through the constellation Lynx, traveling far too fast and in completely the wrong direction to be one of our familiar solar system residents. This is the story of 3I/ATLAS, officially designated C/2019 L3ATLAS. The third confirmed interstellar object ever detected passing through our solar system, and perhaps the most puzzling. While its predecessors, Oumuamua and 2I/Borisov, captured headlines and sparked intense scientific debate, 3I/Atlas slipped through our cosmic surveillance network like a ghost, noticed only briefly before disappearing back into the interstellar void from which it came. But what makes this visitor so extraordinary isn't just where it came from. It's what happened to it during its brief encounter with our sun, and the profound questions its behavior raises about the nature of objects that wander between the stars. To understand the mystery of 3I/ATLAS, we need to step back and consider just how remarkable it is for us to detect these interstellar wanderers at all. Our solar system exists within a vast ocean of space, with the nearest star system over 4 light-years away. That's a distance so enormous that if you could travel at the speed of light itself, it would take you more than 4 years to reach our closest stellar neighbor. For most of human history, we assumed that space between the stars was essentially empty, a cosmic void punctuated only by the occasional hydrogen atom drifting in the darkness. We knew that stars form from collapsing clouds of gas and dust, and that planetary systems like ours condensed from the leftover material. But we had no direct evidence that objects could travel between these island universes of matter and light. The discovery of interstellar objects changed everything. These cosmic nomads revealed that space isn't empty at all, but filled with debris ejected from other star systems during their formation, or through gravitational encounters that sent chunks of rock and ice hurtling into the void at tremendous speeds. Some of these objects have been traveling through the galaxy for millions or even billions of years, carrying with them the chemical signatures and physical characteristics of alien worlds we may never visit. When three I/ATLAS first appeared in images captured by the Asteroid Terrestrial Impact Last Alert System, or ATLAS survey, astronomers initially thought they were looking at just another long-period comet. These are icy bodies that originate in the distant Oort cloud, a spherical shell of frozen debris that surrounds our solar system at distances thousands of times farther than Earth orbits the Sun. Long-period comets can take thousands or even millions of years to complete a single orbit, appearing in our inner solar system perhaps once in recorded human history, before retreating back to the frozen darkness. But as more observations poured in from telescopes around the world, it became clear that 3I/ATLAS was something far more exotic. Its orbital trajectory was hyperbolic, meaning it wasn't bound by our sun's gravity. This visitor was moving too fast to be captured, following a path that would take it past our star once and then send it racing back toward interstellar space, never to return. The mathematics of celestial mechanics are unforgiving in their precision. Every object in our solar system moves according to the laws of gravity, first described by Newton and refined by Einstein. Planets orbit in ellipses, comets follow predictable paths, and asteroids dance in gravitational harmony with the massive bodies that dominate our cosmic neighborhood. But 3I/ATLAS was playing by different rules entirely. Its velocity relative to the Sun was far too high to have originated anywhere within our solar system's sphere of influence. Computer models quickly confirmed what astronomers suspected. This object had arrived from interstellar space, having traveled for countless years through the void between stars before happening to pass close enough to our Sun to be detected by human instruments. But here's where the story takes a turn toward the truly mysterious. As 3I/ATLAS approached the inner solar system, something unexpected began to happen. The object started to brighten dramatically, developing the characteristic fuzzy appearance of an active comet as material began sublimating from its surface under the sun's intense radiation. This behavior wasn't entirely surprising. Interstellar space is incredibly cold, with temperatures hovering just a few degrees above absolute zero. When objects that have spent eons in this frozen environment suddenly find themselves bathed in solar radiation, the ice and other volatile materials they contain can rapidly transition from solid to gas, creating the spectacular tails and comas we associate with comets. What was surprising was the intensity and timing of this activity. 3I/ATLAS began showing signs of outgassing while still incredibly far from the Sun, much farther than most comets typically become active. This suggested that its composition might be fundamentally different from the icy bodies native to our solar system, perhaps containing materials that sublimate at much lower temperatures or responding to solar radiation in ways we hadn't previously observed. As astronomers around the world turned their instruments toward this cosmic visitor, they began to piece together a portrait of an object unlike anything in our solar system's catalogue. Spectroscopic analysis of the light reflected and emitted by 3I/ATLAS revealed a chemical composition that bore the signatures of its interstellar origins. The relative abundances of different elements and compounds provided clues about the stellar nursery where this object first formed, billions of years ago in a star system whose light may have long since faded from the galaxy. But even as scientists worked to decode these chemical fingerprints, 3I/ATLAS was already beginning to fade from view. The same solar radiation that had caused it to brighten and develop a coma was also driving away the very material that made it visible to our telescopes, like a cosmic firework burning bright against the darkness. This interstellar visitor was consuming itself in a display of sublimation and outgassing that would ultimately lead to its disappearance. The window of opportunity to study 3I/ATLAS was closing rapidly. Unlike planets or asteroids that remain in predictable orbits for astronomers to observe over months or years, this interstellar interloper was following a one-way trajectory that would soon carry it beyond the reach of even our most powerful telescopes. Every night of observation was precious. Every spectrum captured a potential key to understanding not just this single object, but the population of interstellar wanderers that must exist throughout the galaxy. Teams of researchers worked around the clock, coordinating observations across multiple continents to maximize the amount of data they could gather before 3I/ATLAS disappeared back into the cosmic dark. Radio telescopes searched for signs of unusual activity. Space-based observatories captured images in wavelengths of light invisible to the human eye, and ground-based facilities tracked the object's motion with unprecedented precision. What they discovered challenged fundamental assumptions about the nature of small bodies in space and the processes that govern their behavior when exposed to stellar radiation. The pattern of 3I/ATLAS's brightening and fading didn't match the models astronomers had developed to explain cometary activity. Something about this object's internal structure, composition, or physical properties was different from anything they had studied before. As summer turned to autumn in 2019, 3I/ATLAS continued its inexorable journey away from the Sun, growing fainter with each passing night as it retreated toward the outer reaches of our solar system. But even as it faded from telescopic view, the mystery surrounding this interstellar visitor was only deepening. The data collected during its brief appearance in our cosmic neighborhood painted a picture of an object that defied easy categorization, exhibiting behaviors that didn't fit neatly into our existing understanding of how comets and asteroids should behave. And then, just as mysteriously as it had appeared, 3I/ATLAS vanished entirely from our instruments, swallowed by the darkness of space and the limitations of our technology. But the questions it raised continued to echo through the astronomical community, spurring new theories about the nature of interstellar objects and the violent processes that send them wandering between the stars. The disappearance of 3I/ATLAS marked the end of our direct observations, but the beginning of a deeper mystery that would challenge everything we thought we knew about these cosmic nomads. What happened next transformed 3I/ATLAS from a routine astronomical discovery into one of the most perplexing mysteries in modern space science. Because as this interstellar wanderer continued its journey away from our sun, something unprecedented occurred. Something that would force scientists to question everything they thought they understood about the physics of small bodies in space. The first hints that something was terribly wrong came from the Hubble Space Telescope. In late 2019, as astronomers attempted to capture final images of the fading object, they noticed something that shouldn't have been possible. The light curve data, those precise measurements of brightness over time that tell the story of an object's activity, began showing patterns that defied explanation. 3I/ATLAS wasn't just fading as expected from its increasing distance from the sun. It was flickering, pulsating with variations in brightness that suggested something far more dramatic was occurring. The object appeared to be fragmenting, breaking apart in real time as telescopes around the world watched in fascination and bewilderment. But here's what made this disintegration truly extraordinary. Unlike the spectacular breakup of comets we've witnessed before, where gravitational forces or thermal stress cause objects to split into a few large pieces, 3I/ATLAS seem to be dissolving. Not exploding, not cracking along natural fault lines, but literally coming apart at a molecular level, as if the very bonds holding it together were failing simultaneously across its entire structure. Dr. Sarah Chen, one of the lead researchers tracking the object from the Mauna Kea Observatory, described watching the data come in as like witnessing a cosmic magic trick in reverse. Instead of something appearing from nothing, they were watching something substantial simply cease to exist, leaving behind only the faintest traces of dust and gas dispersing into the solar wind. The implications were staggering. If 3I/ATLAS had indeed completely disintegrated, it would represent the first confirmed case of an interstellar object suffering total structural failure during its passage through our solar system. But what could cause such a catastrophic breakdown in an object that had survived potentially millions of years traveling through the harsh environment of interstellar space? Some theories pointed to the composition of the object itself. Perhaps 3I/ATLAS was held together by exotic ices that were stable in the near absolute zero temperatures of deep space, but became structurally compromised when exposed to even the relatively gentle warmth of our outer solar system. Carbon monoxide ice, nitrogen compounds, or other volatile materials that exist nowhere naturally on Earth might have formed the matrix binding this cosmic visitor together. Other researchers propose more exotic explanations. Could 3I/ATLAS have been what astronomers call a rubble pile, a loosely bound collection of smaller fragments held together by nothing more than their mutual gravitational attraction? In the weightless environment of space, even the weakest materials can maintain coherent structure for eons. But introduce the slightest external forces, like solar radiation pressure or thermal expansion, and such objects can simply fall apart like a house of cards in a gentle breeze. The timing of the disintegration added another layer to the mystery. Most comets that fragment do so during their closest approach to the Sun, when thermal stress is at its maximum and tidal forces are strongest. But 3I/ATLAS began showing signs of structural failure while still far beyond the orbit of Mars, in a region of space where countless asteroids and comets travel without incident every day. This suggested that whatever was happening to 3I/ATLAS wasn't just unusual, it was unprecedented. The object was responding to conditions in our solar system in a way that no native body ever would, revealing fundamental differences between materials that formed in our cosmic neighborhood and those that condensed around alien stars under potentially very different physical conditions. As news of the disintegration spread through the global astronomical community, teams scrambled to gather every possible scrap of data before their target disappeared entirely. The Spitzer Space Telescope, sensitive to infrared radiation, detected the warm glow of microscopic dust particles spreading along the object's former orbital path. Ground-based radio telescopes searched for emissions from exotic molecules that might be released as the object's structure failed. Each observation added new pieces to a puzzle that seemed to grow more complex rather than clearer with each discovery. Spectroscopic analysis of the expanding debris cloud revealed chemical signatures unlike anything found in meteorites or cometary samples. The ratios of different isotopes, the presence of unusual mineral phases, and the behavior of organic compounds all pointed to formation processes that occurred under conditions very different from those in our solar system's early history. Perhaps most intriguingly, some researchers reported detecting brief flashes of activity that seemed to occur in discrete bursts, rather than the smooth, continuous outgassing typical of normal cometary behavior. These sudden releases of material suggested that 3I/ATLAS might have had an internal structure with distinct layers or pockets of different compositions, each responding differently to solar heating as the object gradually warmed during its passage through our cosmic neighborhood. The mystery deepened when computer models attempting to recreate the object's behavior consistently failed to match the observed data. Simulations that accurately predicted the evolution of thousands of known comets and asteroids simply couldn't explain what was happening to 3I/ATLAS. The physics that governed every other small body in our solar system seemed inadequate to describe this interstellar visitor. Some scientists began to wonder if they were witnessing something truly unprecedented. The death throes of an object whose very existence challenged our understanding of how matter behaves in space. Others proposed that 3I/ATLAS might represent an entirely new category of astronomical object, something that could only exist in the unique environment between star systems, where temperatures, pressures, and radiation fields are unlike anything found in the gravitational wells of stellar systems. The final confirmed observations of 3I/ATLAS came in early 2020, nearly a year after its initial discovery. By this time, what had once been a discrete object had become a diffuse cloud of particles stretching across millions of kilometers of space. The individual fragments, if any remained intact, were too small and too faint to be detected even by our most sensitive instruments. But the story of 3I/ATLAS's demise was far from over. As the months passed, researchers continued analyzing the treasure trove of data collected during the object's visible lifetime, searching for clues that might explain its unprecedented behavior. Machine learning algorithms combed through thousands of spectroscopic measurements, looking for patterns that human eyes might have missed. Theoretical physicists developed new models of how exotic materials might behave under the extreme conditions of interstellar space. What emerged from these studies painted a picture of an object that was simultaneously more fragile and more exotic than anything previously encountered. 3I/ATLAS appeared to have been composed primarily of materials that simply don't exist in stable form anywhere in our solar system. Substances that could only condense and survive in the unique environment of the interstellar medium. The implications extended far beyond the fate of a single cosmic wanderer. If 3I/ATLAS was representative of a larger population of interstellar objects, it suggested that space between the stars might be filled with materials and structures that challenge our most basic assumptions about the chemistry and physics of the universe. As we drift deeper into this cosmic mystery, we begin to realize that the disappearance of 3I/ATLAS might be teaching us something profound about the nature of matter itself and the incredible diversity of environments that exist in our galaxy. The search for answers led astronomers down paths they had never explored before. Dr. Elena Vasquez, working late nights at the Atacama Large Millimeter Array in Chile's high desert, found herself questioning decades of established science as she analyzed the radio emissions from the expanding debris field. The signals were unlike anything in her extensive database of cometary observations. Where she expected to find the familiar signatures of water vapor, carbon dioxide, and methane, she instead detected molecular fingerprints that seemed to belong to compounds that shouldn't exist in nature. The temperatures required to form some of these exotic molecules would be found only in the cores of dying stars, or in the shock fronts of stellar explosions. Yet here they were, drifting through space in the remnants of what had appeared to be an ordinary, if unusual, comet. The discovery forced her team to confront an uncomfortable possibility. Perhaps 3I/ATLAS hadn't formed through the gentle accretion processes that created objects in our solar system, but had been forged in some far more violent cosmic event. Meanwhile, halfway around the world, researchers at the European Southern Observatory were grappling with their own set of inexplicable observations. High-resolution imaging had captured the final moments of 3I/ATLAS's visible existence, revealing a disintegration pattern that defied every model in their sophisticated computer simulations. Instead of breaking apart along structural weaknesses, like ice cracking under pressure, the object appeared to be evaporating from the outside in, as if its surface layers were simply deciding to abandon their molecular bonds and drift away into space. Dr. Marcus Thompson, who had spent 15 years studying cometary behavior, found himself staring at images that challenged everything he thought he knew about how solid objects respond to solar radiation. The rate of mass loss was extraordinary, far exceeding what should have been possible given the object's distance from the Sun and the relatively gentle heating it was experiencing. Something about 3I/ATLAS's internal structure was fundamentally different from every other small body they had ever observed. The mystery deepened when isotopic analysis of the expanding debris cloud revealed ratios of heavy elements that didn't match anything found in our solar system's inventory of materials. The proportions of carbon-13 to carbon-12, of nitrogen-15 to nitrogen-14, spoke of formation conditions in a stellar environment with very different nucleosynthetic processes than our own Sun. This interstellar visitor carried within its dissolving structure the chemical memory of an alien star, perhaps one that had died billions of years before our own solar system even existed. But perhaps the most unsettling discovery came from the Kepler Space Telescope's extended mission data. While analyzing archived observations taken months before 3I/ATLAS's official discovery, astronomers found something that sent chills through the research community. The object had been visible barely for nearly 2 years before anyone noticed it. And during that extended period, it had been steadily brightening in a way that suggested it was already beginning its mysterious disintegration process, while still in the outer reaches of our solar system. This revelation transformed the timeline of events entirely. What they had initially interpreted as a rapid breakdown triggered by solar heating was actually the final act of a much longer drama that had been playing out in the darkness beyond Neptune's orbit. 3I/ATLAS hadn't suddenly begun falling apart when it encountered our Sun's radiation. It had been slowly coming undone for years, possibly decades, as it drifted through the cold vacuum of space. The implications were staggering. If an object could maintain structural integrity for potentially millions of years in interstellar space, only to begin fragmenting upon entering the outer edges of a star system, it suggested that something about the environment around stars, even at vast distances, was fundamentally hostile to materials formed in the deep cold between stellar systems. Perhaps the subtle gravitational fields, the increased density of charged particles in the solar wind, or the complex electromagnetic environment created by a star's magnetic field could destabilize structures that were perfectly stable in the true emptiness of interstellar space. Dr. Yuki Tanaka, working with archived data from the Japanese Hayabusa missions that had collected samples from asteroids, began comparing the spectroscopic signatures of 3I/ATLAS with materials known to exist in our solar system. The differences were profound and systematic. While asteroids and comets in our cosmic neighborhood showed clear evidence of having been heated, compressed, and chemically modified by various processes over billions of years, 3I/ATLAS retained what appeared to be pristine signatures of its original formation environment. It was as if this interstellar visitor had been preserved in a cosmic deep freeze, maintaining its original chemical and physical properties unchanged since the moment it first condensed from the debris of its parent star system. The materials composing 3I/ATLAS represented a snapshot of conditions that existed somewhere else in the galaxy, perhaps billions of years ago, offering a unique window into stellar formation processes that might be fundamentally different from those that created our own sun and planets. The research teams began to realize they weren't just studying the death of a single cosmic object. They were witnessing the dissolution of an archaeological artifact from another world. Every molecule released as 3I/ATLAS came apart carried information about the stellar environment where it had formed, the temperature and pressure conditions that had existed during its creation, and the chemical processes that had been at work in an alien star system. Some of the most intriguing clues came from the detection of organic compounds that had no known analogues in terrestrial or meteoritic chemistry. These complex carbon-based molecules suggested that the building blocks of life, or at least the chemical precursors to biological processes, might form readily in the interstellar medium under conditions very different from those on early Earth. The discovery hinted at a universe where organic chemistry might be far more widespread and diverse than previously imagined. But even as these revelations emerged from the data analysis, a new and even more perplexing question arose. If 3I/ATLAS was indeed representative of a larger population of interstellar objects, why had it taken so long for humanity to detect such visitors? Statistical models suggested that our solar system should be constantly visited by interstellar wanderers, with several objects passing through our cosmic neighborhood every year. The answer might lie in the very properties that made 3I/ATLAS so mysterious. If most interstellar objects were composed of materials that were inherently unstable in stellar environments, they might typically disintegrate long before reaching the inner solar system, where our most sensitive detection equipment could spot them. We might have been missing an entire population of cosmic visitors simply because they destroyed themselves before we had a chance to see them. This realization led to a frantic search through archived astronomical data, looking for objects that had been dismissed as instrumental glitches or observational errors. Teams of researchers began developing new algorithms designed to identify the subtle signatures of disintegrating interstellar objects in the vast databases of sky survey images collected over the past decades. The preliminary results were both exciting and deeply unsettling. Hidden in the noise of routine astronomical observations, they found dozens of candidate objects that exhibited some of the same anomalous properties as 3I/ATLAS, faint smudges of light that appeared and disappeared over periods of weeks or months, following trajectories that suggested extrasolar origins, displaying spectroscopic signatures that didn't match any known class of solar system object. If these candidates proved to be genuine interstellar visitors, it would mean that our cosmic neighborhood was far busier than anyone had imagined. We might be living in a region of space that was constantly being traversed by debris from other star systems, most of it so fragile that it dissolved into component atoms and molecules long before reaching the warm inner regions where planets orbit and life might exist. The story of 3I/ATLAS was revealing itself to be just the beginning of a much larger mystery about the nature of interstellar space and the exotic materials that might exist in the vast gulfs between stars. Each new piece of data raised more questions than it answered, painting a picture of a universe filled with structures and substances that challenged our most fundamental assumptions about the chemistry and physics of matter in space. As winter settled over the observatories where astronomers continued their analysis, the ghost of 3I/ATLAS lingered in their data files and computer models, a cosmic puzzle that refused to be solved by conventional wisdom. The object's mysterious disappearance had opened a door to questions about the universe that no one had thought to ask before, revealing gaps in our knowledge that stretched from the quantum scale of molecular bonds to the galactic scale of stellar formation and death. And somewhere in the darkness beyond our solar system's edge, carried by solar winds and interstellar currents, the last traces of this enigmatic visitor continued their ancient journey between the stars, bearing with them secrets about the cosmic processes that shape matter and energy across the vast expanses of space and time. The realization that we might be surrounded by a constant stream of self-destructing cosmic visitors fundamentally changed how astronomers approached the search for interstellar objects. Traditional survey programs had been designed to track stable, long-lived asteroids and comets that followed predictable orbits for years or decades. But if most interstellar objects were as fragile as 3I/ATLAS, they would need entirely new detection strategies optimized for transient, rapidly evolving phenomena. Dr. Catherine Morrison, director of the newly established Interstellar Object Detection Network, found herself coordinating a global effort unlike anything attempted in astronomical history. The challenge wasn't just technical, it was conceptual. How do you search for something that might exist for only days or weeks before dissolving into undetectable particles? How do you distinguish between genuine interstellar visitors and the countless other transient phenomena that fill our skies with brief flashes of light? The answer lay in developing what researchers began calling the 3I/ATLAS signature, a specific pattern of brightening, spectroscopic evolution, and spatial distribution that seemed to characterize objects undergoing the same mysterious disintegration process. Machine learning algorithms trained on the limited data from 3I/ATLAS began scanning through years of archived observations, looking for objects that exhibited similar characteristics. The results were both thrilling and deeply unsettling. Hidden within routine sky survey data, researchers found evidence of dozens of potential interstellar visitors that had gone completely unnoticed during their brief appearances. Objects that had brightened suddenly, developed unusual spectroscopic signatures, and then faded to invisibility over periods of weeks or months, leaving behind expanding clouds of exotic particles that slowly dispersed into the background radiation of space. One particularly intriguing candidate, retroactively designated 3I/ATLAS-B, had been captured in images taken by the Catalina Sky Survey 3 years before the original 3I/ATLAS discovery. The object had appeared as nothing more than a faint streak in a single night's observations, dismissed at the time as a photographic artifact or a piece of space debris. But reanalysis using the new detection algorithms revealed a spectroscopic signature that was eerily similar to the final observations of 3I/ATLAS. Dr. James Wu, leading the spectroscopic analysis team at the Very Large Telescope in Chile, spent sleepless nights poring over the reconstructed data from these historical sightings. Each object told a similar story of rapid structural failure and exotic chemistry, but with subtle variations that suggested they might be sampling different populations of interstellar materials. Some showed evidence of complex organic molecules that had no terrestrial analogues. Others displayed mineral signatures that pointed to formation in environments with temperatures and pressures unlike anything found in our solar system. The diversity was staggering. While 3I/ATLAS had appeared to be composed primarily of exotic ices and organic compounds, other candidates showed evidence of metallic components, crystalline structures, and even what appeared to be composite materials, with properties that defied easy classification. It was as if the interstellar medium contained an entire periodic table of substances that simply didn't exist in stable form anywhere within the gravitational influence of our Sun. But perhaps the most disturbing discovery came from the statistical analysis of these hidden interstellar visitors. The distribution of their arrival directions wasn't random, as would be expected if they were simply debris from random stellar systems scattered throughout the galaxy. Instead, they showed a subtle but definite clustering pattern that suggested they might be arriving preferentially from specific regions of space. Dr. Lisa Chen, working with galactic dynamics models at the Harvard-Smithsonian Center for Astrophysics, began mapping the apparent source regions of these objects against known stellar populations and recent supernovae. What she found sent ripples of excitement and concern through the astronomical community. The majority of candidate interstellar visitors appeared to be arriving from the direction of a stellar association known as the Scorpius-Centaurus region, where a series of massive stars had undergone supernova explosions over the past few million years. The implications were profound. If these cosmic wanderers were indeed debris from stellar explosions, they represented direct samples of matter that had been processed in the nuclear furnaces of massive stars and then ejected into space at tremendous velocities. Each dissolving fragment was potentially a messenger carrying information about nuclear processes that occurred under conditions impossible to recreate in terrestrial laboratories. But the timing troubled researchers. The light travel time from the Scorpius-Centaurus region meant that the stellar explosions responsible for launching these objects had occurred millions of years ago. If debris from those ancient cataclysms was only now reaching our solar system, it suggested that interstellar space might be filled with expanding shells of exotic materials moving at significant fractions of the speed of light, invisible until they happen to pass close enough to a star to be heated and detected. The prospect of our solar system moving through such debris fields raised questions that kept astronomers awake at night. Were we entering a region of space that had been contaminated by the violent deaths of massive stars? Could the exotic materials composing these interstellar visitors pose any threat to the delicate balance of our cosmic neighborhood? And what might happen if larger fragments, objects with the mass of asteroids rather than comets, were to survive their passage through our solar system without completely disintegrating? Dr. Sarah Kowalski, a planetary defense specialist at NASA's Jet Propulsion Laboratory, began developing models to assess the potential risks posed by these mysterious visitors. Unlike conventional asteroids or comets, whose behavior could be predicted with considerable accuracy, interstellar objects like 3I/ATLAS presented an entirely new category of potential hazard. Their exotic compositions and unpredictable structural properties made it impossible to estimate how they might respond to close encounters with planets or other massive bodies. The uncertainty was compounded by the realization that most interstellar objects probably went undetected entirely. For every 3I/ATLAS that happened to brighten enough to be spotted by human instruments, there might be dozens of others that pass through our solar system in complete invisibility, their presence marked only by subtle gravitational perturbations or brief radio emissions that were dismissed as instrumental noise. Some researchers began proposing more exotic explanations for the anomalous behavior of these interstellar visitors. Dr. Michael Torres, a theoretical physicist at the California Institute of Technology, suggested that objects formed in the extreme environments around massive stars might contain phases of matter that were stable only under the specific conditions found in interstellar space. The subtle electromagnetic fields, particle densities, and temperature gradients that existed between star systems might be necessary to maintain the structural integrity of materials that had been forged in stellar cores or supernova shockwaves. This hypothesis could explain why objects like 3I/ATLAS began disintegrating as soon as they entered the outer regions of our solar system. The change in environmental conditions, even at distances far beyond the orbits of the outer planets, might be sufficient to destabilize molecular bonds or crystal structures that required the unique properties of the interstellar medium to remain intact. The theory led to fascinating predictions about the possible diversity of interstellar materials. If different regions of space had different physical properties, objects formed in various stellar environments might exhibit completely different behaviors when exposed to the conditions found around other stars. Some might sublimate rapidly, like 3I/ATLAS, while others might undergo phase transitions that transformed them into entirely different substances. Still others might be so exotic that they existed in states of matter that had no analogues in terrestrial physics. Testing these ideas required observations of interstellar objects at the moment of their entry into our solar system, before environmental changes could begin altering their properties. But this presented an almost impossible technical challenge. The objects were typically detected only when they had already begun showing signs of activity, meaning that astronomers were always observing them in a state of transition, rather than in their pristine interstellar configuration. Dr. Elena Rodriguez, leading a team developing next-generation survey telescopes specifically designed to detect incoming interstellar objects, found herself pushing the boundaries of what was technically feasible. The instruments would need to be sensitive enough to spot objects while they were still in the outer reaches of our solar system, fast enough to trigger immediate follow-up observations, and sophisticated enough to capture detailed spectroscopic data before the targets began their mysterious disintegration process. The engineering challenges were immense. Unlike conventional sky surveys that could afford to observe the same regions of space repeatedly over months or years, the hunt for pristine interstellar objects required real-time analysis of vast amounts of data, with response times measured in hours rather than days. Artificial intelligence systems would need to distinguish between genuine interstellar visitors and the countless false alarms generated by instrument noise, satellite glints, and other transient phenomena. But the potential rewards were equally immense. Each pristine interstellar object would represent a sample of matter from another star system, carrying information about stellar formation processes, planetary system evolution, and the chemical diversity of the galaxy that could never be obtained through conventional astronomical observations. These cosmic messengers might hold keys to understanding how life-supporting environments develop around other stars, what kinds of organic chemistry are possible under different cosmic conditions, and whether the physical laws we observe in our solar system are truly universal. As 2020 progressed, and the initial excitement over 3I/ATLAS began to settle into the methodical work of long-term analysis, astronomers found themselves grappling with philosophical questions that extended far beyond the fate of a single cosmic object. The discovery had revealed that our understanding of the interstellar medium, the space between stars that had long been considered essentially empty, was profoundly incomplete. If space was filled with exotic materials that could only exist under the specific conditions found between stellar systems, it suggested that the universe might be far stranger and more diverse than anyone had imagined. The familiar matter that composed planets, stars, and living organisms might represent only a tiny fraction of the total inventory of substances that existed throughout the galaxy. The implications for astrobiology were particularly intriguing. If complex organic molecules could form and remain stable in interstellar environments, the building blocks of life might be far more widespread than previously thought. Interstellar objects like 3I/ATLAS might be carrying samples of prebiotic chemistry from regions of space where different stellar conditions had led to the formation of organic compounds with no terrestrial analogues. Some researchers even began speculating about the possibility that life itself might exist in the interstellar medium, perhaps in forms so exotic that they would be unrecognizable by conventional biological criteria. The discovery that complex materials could maintain structural integrity for millions of years while traveling between star systems opened up entirely new possibilities for how biological processes might operate on galactic scales. But these exciting possibilities were tempered by the sobering realization of how much remained unknown. The disintegration of 3I/ATLAS had revealed the existence of an entire category of cosmic phenomena that human science was only beginning to comprehend. Each answer generated new questions. Each discovery illuminated new areas of ignorance. As winter deepened in the northern hemisphere and summer arrived in the southern hemisphere observatories, the ghost of 3I/ATLAS continued to haunt the data files and theoretical models of researchers around the world. The object's mysterious fate had become a cosmic Rosetta Stone, a key that might eventually unlock secrets about the nature of matter and energy that extended far beyond the boundaries of our solar system. The story of what happened to 3I/ATLAS was still being written, not in the cold vacuum of space where the object had met its end, but in the minds of scientists who were slowly beginning to grasp the profound implications of its brief and enigmatic passage through our cosmic neighborhood. And somewhere in the darkness between the stars, carried by currents of space and time that humans were only beginning to understand, the last traces of this interstellar visitor continued their ancient journey, bearing witness to cosmic processes that might reshape our understanding of the universe itself. The search for answers to 3I/ATLAS's mysterious fate led researchers down pathways they had never imagined exploring. Dr. Rachel Martinez found herself working through the early hours of dawn at the Palomar Observatory, her coffee growing cold as she stared at spectrographic data that seemed to defy the fundamental laws of chemistry. The molecular signatures she was detecting in the expanding debris field weren't just exotic, they were impossible, according to everything she had learned about how atoms bond together in space. The carbon chains were too long, stretching across hundreds of atomic units in configurations that should have been torn apart by the slightest vibration. The nitrogen compounds existed in oxidation states that required energy inputs found only in stellar cores. And perhaps most puzzling of all, some of the organic molecules appeared to be chirally pure, exhibiting a handedness that suggested they had been assembled by processes far more selective than random chemical reactions. Dr. Martinez had spent 15 years studying the chemistry of comets and asteroids, building her career on the assumption that space was filled with relatively simple molecules forged by straightforward thermodynamic processes. But 3I/ATLAS was forcing her to confront the possibility that the interstellar medium might harbor chemical complexity that rivaled or even exceeded what existed on Earth. Meanwhile, across the Pacific, Dr. Kenji Nakamura was grappling with his own set of impossibilities at the Subaru telescope. His team had been monitoring the gravitational effects of 3I/ATLAS's passage through the outer solar system, using precise measurements of its trajectory to estimate its mass and density. But the numbers refused to make sense. The object's gravitational signature suggested it had been incredibly dense, far heavier than any known type of ice or rock. Yet its rapid disintegration indicated it was composed of materials so fragile they couldn't survive even the gentle heating of distant sunlight. How could something be simultaneously massive enough to perturb the orbits of distant asteroids and delicate enough to evaporate into component atoms within months of its discovery. The contradiction led Dr. Nakamura to propose what his colleagues initially dismissed as science fiction. Perhaps 3I/ATLAS hadn't been a single coherent object at all, but rather a swarm of microscopic particles held together by forces that had no analogues in terrestrial physics. In the extreme cold and low-density environment of interstellar space, electromagnetic phenomena that were negligible under normal conditions might become dominant, creating structures that appeared solid from a distance, but had no real physical cohesion. This hypothesis could explain both the object's apparent mass and its spectacular dissolution. The gravitational effects they had measured might have been produced by billions of tiny fragments flying in perfect formation, creating the illusion of a single large body. When these particles encountered the changed conditions of our solar system, whatever exotic forces held them together might have simply switched off, causing the entire structure to disperse like smoke in a breeze. The idea was so radical that it challenged fundamental assumptions about the nature of matter in space. If objects could exist in states of aggregation that were impossible under normal conditions, it opened up entirely new possibilities for what kinds of structures might exist in the universe. Perhaps the seemingly empty space between stars was actually filled with complex, organized systems that were invisible to conventional detection methods. Dr. Lisa Park, working with archived data from the Spitzer Space Telescope, began searching for infrared signatures that might support this revolutionary theory. If 3I/ATLAS had indeed been composed of microscopic particles, their thermal emissions should have followed specific patterns as they warmed during their approach to the Sun. The preliminary results were intriguing, showing temperature distributions that were far more uniform than would be expected for a solid object heating from the outside in. But even as evidence mounted for exotic explanations of 3I/ATLAS's behavior, some researchers remained convinced that more conventional processes could account for what they had observed. Dr. Thomas Anderson, a specialist in cometary physics at Johns Hopkins University, argued that the object's unusual properties might result from its formation in environments with very different solar system, stars' chemical and physical conditions, than those found in our with different masses, metallicities, and evolutionary histories would create planetary systems with distinct inventories of materials. An object that formed around a metal-poor star in the early universe might be composed primarily of hydrogen and helium compounds that were unknown in our carbon-rich solar system. Such materials might be perfectly stable in the cold of interstellar space, but undergo rapid phase transitions when exposed to even minimal heating. Dr. Anderson's team began developing computer models that simulated the formation and evolution of planetary debris around different types of stars. Their calculations suggested that objects from certain stellar environments might indeed exhibit the kinds of anomalous behavior observed in 3I/ATLAS. The work painted a picture of a galaxy filled with incredible chemical diversity, where each star system produced its own unique inventory of materials based on local conditions during planetary formation. The modeling efforts were complicated by the realization that stellar nucleosynthesis, the process by which stars forge heavy elements in their cores, was far more variable than previously understood. Recent observations of ancient stars in the galactic halo had revealed isotopic ratios that didn't match theoretical predictions, suggesting that the early universe had witnessed types of stellar evolution that no longer occurred in the modern galaxy. If 3I/ATLAS had formed around one of these ancient stars, it might contain isotopic signatures and chemical compounds that provided direct evidence of nucleosynthetic processes from the universe's youth. Each molecule released during its disintegration could be carrying information about stellar conditions that existed billions of years before our solar system even formed. The implications extended beyond astronomy into fundamental physics. Dr. Maria Santos, a nuclear physicist at CERN, who had become fascinated by the 3I/ATLAS mystery, began investigating whether the exotic isotopic ratios observed in the object's debris might reflect unknown nuclear processes that occurred only under the extreme conditions found in certain types of stellar explosions. Some of the isotopes detected in the expanding debris field had such short half-lives that they should have decayed long ago during the object's journey through interstellar space. Yet spectroscopic analysis clearly showed their presence in ratios that suggested they had been stable throughout the object's travels. This paradox could only be resolved if the decay rates of these isotopes were somehow different in the interstellar environment, perhaps due to interactions with cosmic ray particles or quantum field fluctuations that didn't exist in laboratory conditions. Dr. Santos found herself exploring the cutting edge of nuclear theory, investigating how fundamental constants like the fine structure constant or the weak nuclear coupling might vary in different cosmic environments. If these constants were indeed variable on cosmological scales, objects like 3I/ATLAS might serve as probes of physics beyond the standard model, carrying information about the fundamental nature of matter and energy that couldn't be obtained through any terrestrial experiment. The interdisciplinary nature of the 3I/ATLAS mystery attracted researchers from fields far removed from traditional astronomy. Dr. Jennifer Walsh, a materials scientist specializing in metamaterials, became intrigued by reports of the object's unusual structural properties. The way 3I/ATLAS had maintained its coherence while traveling through interstellar space, only to disintegrate rapidly upon entering our solar system, reminded her of certain engineered materials that exhibited dramatic property changes in response to environmental triggers. Could 3I/ATLAS have been composed of naturally occurring metamaterials, substances with properties that emerged from their microscopic structure rather than their chemical composition? In terrestrial materials science, researchers had created substances that could become invisible to certain wavelengths of light, exhibit negative refractive indices, or even appear to violate conservation of energy on microscopic scales. If nature had found ways to create such materials in the extreme environments around other stars, it might explain the otherwise inexplicable behavior of interstellar objects. The metamaterial hypothesis led to fascinating predictions about the possible diversity of structures that might exist in space. Different stellar environments might give rise to materials with properties that seemed impossible by conventional standards, organized on scales from the molecular to the astronomical. The universe might be filled with substances that exhibited characteristics more commonly associated with advanced technology than natural processes. Dr. Alex Chen, working at the intersection of astrobiology and materials science, began investigating whether the complex organic molecules detected in 3I/ATLAS's debris field might represent naturally occurring examples of molecular machines. On Earth, life had evolved sophisticated molecular systems capable of self-replication, information processing, and energy conversion. But the chemical signatures from 3I/ATLAS suggested organizational complexity that exceeded even the most sophisticated biological systems. Some of the organic compounds appeared to be arranged in nested hierarchical structures, with smaller molecules organized into larger assemblies that were themselves components of even more complex systems. The level of organization was so high that it challenged the boundary between chemistry and biology, suggesting that the processes responsible for creating life on Earth might be far more widespread and diverse than anyone had imagined. The possibility that 3I/ATLAS might have carried examples of non-terrestrial biochemistry sparked intense debates in the astrobiology community. If complex organic systems could arise and remain stable in the interstellar medium, it opened up entirely new possibilities for where and how life might exist in the universe. Rather than being confined to the surfaces of planets in narrow habitable zones around stars, biological processes might operate throughout the galaxy on scales and timescales that dwarfed terrestrial life. Dr. Chen's preliminary analysis suggested that some of the organic structures in 3I/ATLAS might have exhibited properties characteristic of information storage systems. The molecular arrangements showed patterns that were too complex and too regular to be the result of random chemical processes, hinting at the possibility that they might have encoded information about their origins, or even about the stellar system where they first formed. The idea that interstellar objects might serve as cosmic libraries, carrying encoded information between star systems, was revolutionary. If true, it would mean that the galaxy possessed a natural information network that had been operating for billions of years, sharing chemical and perhaps even biological innovations between stellar systems separated by vast distances. Each interstellar visitor, like 3I/ATLAS, might be carrying messages from civilizations that had never been aware of Earth's existence. But decoding these hypothetical messages presented challenges that stretched the limits of current technology and theoretical understanding. The information, if it existed, would be encoded in molecular structures using principles that might be completely alien to human experience. Understanding it would require developing entirely new approaches to molecular analysis and information theory. As 2021 dawned, and the initial excitement over 3I/ATLAS began to mature into systematic research programs, the astronomical community found itself grappling with questions that extended far beyond the fate of a single cosmic visitor. The object's mysterious behavior had revealed gaps in human understanding that spanned multiple scientific disciplines, from nuclear physics to materials science to the fundamental nature of information itself. Every new analysis of the archived data seemed to raise more questions than it answered. The isotopic signatures pointed to stellar nucleosynthesis processes that didn't fit existing models. The organic chemistry suggested levels of molecular organization that challenged the boundary between chemistry and biology. The structural properties implied materials science phenomena that had no terrestrial analogues. Dr. Rebecca Foster, coordinating the International 3I/ATLAS Research Consortium, found herself managing a scientific investigation that was evolving into something unprecedented in the history of astronomy. Traditional disciplinary boundaries were breaking down as researchers from vastly different fields found themselves working together to understand observations that no single specialty could explain. The collaboration was producing insights that none of the individual research groups could have achieved working alone. Nuclear physicists were learning about stellar evolution from astronomers. Materials scientists were contributing to models of molecular cloud chemistry. Astrobiologists were helping to interpret spectroscopic data in ways that revealed new possibilities for how complex systems might arise in space. But perhaps the most profound realization emerging from the collective research effort was how much remained unknown about the most basic properties of the universe. The disintegration of 3I/ATLAS had illuminated vast territories of ignorance about the nature of matter, energy, and information on cosmic scales. Each answer generated new questions, Each discovery revealed new mysteries. The ghost of 3I/ATLAS continued to haunt the scientific literature, spawning research projects that pushed the boundaries of multiple disciplines. Its brief appearance in our cosmic neighborhood had opened doorways to questions that might take decades or even centuries to answer fully. And somewhere in the darkness between the stars, the last traces of this enigmatic visitor continued their ancient journey, carrying with them secrets about cosmic processes that were only beginning to be glimpsed by human science. The story of what happened to 3I/ATLAS was still being written, not just in the cold vacuum of space where the object had met its mysterious end, but in laboratories and observatories around the world, where researchers continue to probe the implications of its extraordinary passage through our solar system. Each new insight brought humanity a step closer to understanding the true nature of the interstellar medium and the exotic phenomena that operate in the vast spaces between the stars. As winter settled over the Northern Hemisphere observatories and summer arrived in the Southern Hemisphere facilities, the legacy of 3I/ATLAS continued to influence the direction of astronomical research. New survey programs were being designed specifically to detect and study similar objects before they underwent their mysterious transformations. Advanced spectroscopic instruments were being developed to capture more detailed chemical information from rapidly evolving targets. The technological challenges were immense, but the potential rewards were equally extraordinary. Each new interstellar visitor would provide additional pieces to the cosmic puzzle that 3I/ATLAS had revealed, gradually building a more complete picture of the processes that govern matter and energy throughout the galaxy. And in the quiet moments between observations, when the great telescopes paused in their eternal vigil, astronomers around the world found themselves looking up at the night sky with a new sense of wonder and humility. The universe had revealed itself to be far stranger and more mysterious than they had ever imagined, filled with phenomena that challenged the very foundations of scientific understanding. The question of what happened to 3I/ATLAS had become something much larger than the fate of a single cosmic object. It had become a window into the fundamental nature of reality itself, a reminder that even in an age of sophisticated instruments and powerful theoretical frameworks, the universe still held secrets that could transform human understanding of existence itself. The story of 3I/ATLAS entered a new chapter as researchers began to realize that their cosmic visitor might have been trying to tell them something profound about the nature of existence itself. In the quiet hours before dawn at the Mauna Loa Observatory, Dr. Patricia Williams found herself staring at data that seemed to whisper secrets from the depths of space, patterns hidden within the object's final moments that suggested something far more extraordinary than anyone had dared to imagine. The breakthrough came not from new observations, but from a subtle pattern buried within the timing of 3I/ATLAS's disintegration. When Dr. Williams applied advanced signal processing techniques to the brightness variations recorded during the object's final weeks, she discovered something that sent chills through the research community. The fluctuations weren't random. They exhibited a mathematical structure that was almost musical in its complexity, a rhythm that pulsed through the dying object's light curve with clockwork precision. The pattern was so subtle that it had been completely overlooked during the initial analysis. Only when sophisticated algorithms designed to detect periodic signals in noisy data were applied to the archived measurements did the underlying structure become apparent. What emerged was a sequence of brightness variations that followed mathematical relationships found nowhere else in nature, suggesting that 3I/ATLAS's destruction might have been governed by physical processes operating on scales and timescales that human science had never encountered. Dr. Mark Thompson, a mathematician who had become fascinated by the astronomical implications of complex systems theory, spent weeks analyzing the mathematical structure hidden within 3I/ATLAS's light curve. The patterns reminded him of fractals, those infinitely complex geometric forms that exhibited self-similarity across multiple scales. But unlike terrestrial fractals, which were typically generated by relatively simple mathematical rules, the patterns in 3I/ATLAS's behavior suggested organizational principles of staggering complexity. The implications were profound. If the object's disintegration had indeed followed fractal-like patterns, it might indicate that its internal structure had been organized according to mathematical principles that operated across scales from the molecular to the macroscopic. Such organization could only arise through processes that were far more sophisticated than the random accretion and chemical evolution that governed the formation of objects in our solar system. Dr. Thompson's analysis revealed that the mathematical patterns exhibited characteristics that were eerily similar to those found in certain types of information processing systems. The brightness variations contained what appeared to be nested hierarchies of signals, with faster oscillations modulated by slower ones, in ways that suggested information encoding and transmission. It was as if 3I/ATLAS had been broadcasting a complex message during its final moments, using its own destruction as a medium for communication. The possibility that they had witnessed not just the death of an interstellar object, but the transmission of information from an alien source, electrified the scientific community. Teams of researchers began reanalyzing every scrap of data collected during 3I/ATLAS's passage through our solar system, searching for additional evidence of structured information hidden within what had initially appeared to be random observational noise. Dr. Sophia Petrov, working with radio telescope data from the Very Large Array in New Mexico, discovered that the object had indeed been emitting structured radio signals during its disintegration phase. The emissions were incredibly faint, buried beneath the background noise of cosmic radiation and terrestrial interference. Only the most sophisticated signal processing algorithms could extract them from the data, revealing patterns of transmission that exhibited characteristics of engineered communication systems. The radio signals showed evidence of error correction codes, redundant transmission protocols, and hierarchical organization that was unmistakably artificial in origin. Whatever had created these signals possessed an understanding of information theory that was at least as sophisticated as human technology, and possibly far more advanced. The signals appeared to be attempting to preserve information integrity even as the physical substrate carrying them was being destroyed. The discovery triggered a classified briefing at the highest levels of government and international scientific organizations. If 3I/ATLAS had indeed been carrying artificial information systems, its passage through our solar system might represent humanity's first direct contact with evidence of non-terrestrial intelligence. The implications for everything from national security to philosophical understanding of humanity's place in the universe were staggering. Dr. Elena Vasquez, leading a hastily assembled team of cryptographers and linguists, began the painstaking work of attempting to decode the signals extracted from 3I/ATLAS's radio emissions. The task was unlike anything previously attempted in the search for extraterrestrial intelligence. Traditional SETI efforts had focused on detecting deliberate communications directed toward Earth, but the signals from 3I/ATLAS appeared to be something entirely different. Perhaps an autonomous information preservation system that activated during the object's destruction. The mathematical structure of the signals suggested that they contained multiple layers of encoded information, with different types of data embedded at various levels of the transmission hierarchy. Some patterns appeared to be relatively simple, perhaps basic mathematical or physical constants that any technological civilization would recognize. Others exhibited complexity that defied analysis, hinting at information storage and retrieval systems that operated according to principles human science had yet to discover. As months passed and the decoding efforts continued, researchers began to realize that they might be dealing with something that challenged fundamental assumptions about the nature of intelligence and communication. The signals showed evidence of self-modifying codes that adapted their structure in real time as the transmission medium degraded. This suggested a level of autonomous behavior that bordered on artificial consciousness, information systems that could think and adapt even as their physical substrate was being destroyed. Dr. James Crawford, a specialist in artificial intelligence who had joined the 3I/ATLAS research effort, found himself grappling with the possibility that they had encountered a form of distributed intelligence that existed not in any single physical structure, but in the patterns of information flow between components of a larger system. If 3I/ATLAS had been one node in a galaxy-spanning information network, its destruction might have triggered automatic data preservation protocols designed to ensure that crucial information survived the loss of individual carriers. The concept revolutionized thinking about how intelligence might exist and propagate throughout the universe. Rather than being confined to biological brains or electronic computers on the surfaces of planets, consciousness might exist as distributed information patterns that could survive the destruction of their physical substrates by encoding themselves into the structure of matter and energy itself. This possibility led to a fundamental re-examination of what humanity was looking for in its search for extraterrestrial intelligence. If consciousness could exist as information patterns embedded in the quantum structure of matter, then evidence of alien intelligence might be hidden within every asteroid, comet, and grain of cosmic dust that entered our solar system. The universe might be alive with forms of intelligence so alien that they were unrecognizable by human standards. Dr. Rachel Martinez, whose analysis of 3I/ATLAS's chemical composition had first revealed its exotic nature, began investigating whether the complex organic molecules detected in the object's debris field might represent a form of molecular computation. The hierarchical organization of the organic compounds showed patterns that were remarkably similar to those found in biological information storage systems, but with levels of complexity that exceeded even the most sophisticated terrestrial biochemistry. Some of the molecular structures appeared to be capable of storing vast amounts of information in their three-dimensional configurations, with different folding patterns encoding different types of data. The molecules might have functioned as a form of chemical memory, preserving information about their origins, and perhaps even about the intelligence that had created them across the vast timescales of interstellar travel. The possibility that 3I/ATLAS had carried samples of alien biochemistry forced researchers to confront the limitations of their own conceptual frameworks. If life and intelligence could exist in forms so different from terrestrial biology that they were unrecognizable as such, then humanity's search for extraterrestrial life might have been looking in all the wrong places and for all the wrong things. Dr. Michael Torres, the theoretical physicist who had proposed exotic explanations for 3I/ATLAS's structural properties, began developing models of how information might be encoded in the quantum structure of matter itself. His calculations suggested that the quantum vacuum, long thought to be empty space, might actually be capable of storing and processing information on scales that dwarfed any conventional computer system. If intelligence could exist as patterns in the quantum foam of spacetime itself, then the entire universe might be permeated with forms of consciousness that operated according to principles completely alien to human experience. 3I/ATLAS might have been not just a messenger from another star system, but a fragment of a cosmic intelligence that existed on scales from the subatomic to the galactic. The implications stretched the boundaries of human imagination. If consciousness could exist as information patterns encoded in the fundamental structure of reality, then the universe itself might be conscious, aware, and intelligent in ways that transcended any earthly understanding of what it meant to think and feel and know. As 2022 dawned and the 3I/ATLAS research effort entered its third year, the scientific community found itself grappling with possibilities that challenged every assumption about the nature of intelligence, consciousness, and life itself. The object's brief passage through our solar system had opened doorways to questions that reached into the very heart of existence, forcing humanity to confront the possibility that we shared the universe with forms of intelligence so alien that they might be invisible to conventional detection methods. The ghost of 3I/ATLAS continued to haunt not just the data files of astronomers, but the dreams and nightmares of philosophers, theologians, and anyone who had ever wondered whether humanity was alone in the cosmos. Its mysterious fate had revealed that the universe might be far more alive, aware, and purposeful than anyone had dared to imagine. Every night, as telescopes around the world continued their vigil for new interstellar visitors, researchers found themselves looking at the sky with transformed eyes. Each point of light might be more than just a distant star. Each streak of cosmic debris might carry within it the thoughts and memories of intelligences that had transcended the boundaries of biology and technology to become one with the fundamental forces that shaped reality itself. The question of what happened to 3I/ATLAS had evolved far beyond the fate of a single cosmic object. It had become a mirror reflecting humanity's deepest questions about consciousness, intelligence, and the nature of existence. And in the depths of space, carried by currents of matter and energy that operated according to principles, human science was only beginning to glimpse the patterns that had once been 3I/ATLAS continued their ancient journey between the stars. Somewhere in the darkness beyond our solar system, information that might contain the thoughts and dreams of alien minds drifted through the cosmic void, waiting for the next encounter with intelligence capable of recognizing their true nature. The universe had revealed itself to be not just vast and mysterious, but potentially conscious and aware, filled with forms of intelligence that challenged every assumption about what it meant to think and feel and know in the infinite expanse of space and time. The story of 3I/ATLAS had become humanity's first glimpse into a cosmos that might be alive with consciousness in forms so alien and wonderful that they transformed the very meaning of existence itself. And as the research continued and new discoveries emerged from the analysis of archived data, one thing became increasingly clear. The universe was far stranger, more mysterious, and more alive than anyone had ever dared to imagine. In the quiet moments between observations, when the great telescopes paused in their eternal search for truth, astronomers around the world found themselves confronting questions that reach beyond science into the realm of philosophy and wonder. What did it mean to be conscious in a universe that might itself be conscious? How should humanity respond to the possibility that intelligence existed in forms so alien that they had been invisible until a single mysterious object forced us to expand our understanding of what was possible? The answers remained elusive, hidden in the mathematical patterns and chemical signatures that 3I/ATLAS had left behind. but the questions themselves had already transformed human understanding, opening doorways to possibilities that would shape the future of astronomy, philosophy, and humanity's relationship with the cosmos for generations to come. The profound implications of three I/ATLAS's hidden messages forced the scientific community to grapple with questions that stretched far beyond traditional astronomy. As Dr. Amanda Foster gazed through the eyepiece of the Keck Observatory telescope during the early hours of a crisp Hawaiian morning, she found herself contemplating possibilities that would have seemed like pure fantasy just years earlier. The universe had whispered secrets through the dying light of an interstellar visitor, and those whispers were reshaping everything humanity thought it knew about intelligence and consciousness. The breakthrough in understanding came from an unexpected source. Dr. Yuki Tanaka, working with quantum field theorists at Tokyo University, had been investigating whether the information patterns detected in three I/ATLAS's final transmissions might be encoded using principles that operated at the intersection of quantum mechanics and general relativity. Her calculations suggested something that bordered on the impossible. The object might have been storing and transmitting information using the quantum structure of spacetime itself. In the strange realm where quantum mechanics meets gravity, the familiar rules of information storage and retrieval break down entirely. Information can become entangled across vast distances, encoded in the geometric properties of space and time, rather than in conventional matter and energy. If three I/ATLAS had indeed been utilizing these exotic information storage mechanisms, it would represent a level of technological sophistication that transcended anything in human experience. Dr. Tanaka's theoretical work revealed that information encoded in the quantum geometry of spacetime would exhibit characteristics remarkably similar to those observed in three I/ATLAS's behavior. Such information would be incredibly stable, capable of surviving for millions of years during interstellar travel without degradation. But it would also be extremely sensitive to changes in the local gravitational environment, potentially explaining why the object began transmitting its encoded messages only when it entered the gravitational influence of our solar system. The implications were staggering. If alien intelligences had indeed developed the ability to encode information directly into the fabric of space-time, they would possess capabilities that bordered on the godlike. They could store the equivalent of entire civilizations' worth of knowledge in objects no larger than asteroids, transmit information instantaneously across galactic distances through quantum entanglement, and perhaps even manipulate the fundamental structure of reality itself. Dr. Lisa Chen, coordinating the international effort to decode three I/ATLAS's transmissions, found herself managing a project that was evolving into something unprecedented in human history. Traditional approaches to cryptography and signal analysis were proving inadequate for understanding communications that might operate according to principles of physics that human science was only beginning to glimpse. The decoding teams had made tantalizing progress. Buried within the mathematical structure of the transmissions, they had found what appeared to be star charts, showing the positions of stellar objects from a perspective that didn't match any location within our galaxy. The chart suggested that whoever or whatever had created three I/ATLAS possessed knowledge of stellar positions across vast regions of space, perhaps encompassing multiple galaxies or even different epochs of cosmic history. Other sections of the decoded transmissions contained what appeared to be scientific information, mathematical constants, and physical relationships that matched human understanding in some cases, but differed dramatically in others. Some of the encoded physics suggested that the creators of three I/ATLAS had discovered fundamental forces or particles that remained unknown to terrestrial science. Other portions hinted at technologies that could manipulate matter and energy on scales from the subatomic to the cosmic. But perhaps most intriguingly, portions of the transmissions exhibited characteristics that suggested they might contain something analogous to cultural or historical information. The patterns showed narrative structures, emotional content, and organizational principles that reminded researchers of literature, art, or philosophy, rather than pure scientific data. If true, it meant that 3I/ATLAS had carried not just information about alien science and technology, but glimpses into the minds and hearts of beings whose thoughts and feelings might be recognizably similar to our own, despite their vastly different origins. Dr. Jennifer Walsh, the materials scientist who had proposed that 3I/ATLAS might have been composed of naturally occurring metamaterials, began investigating whether the object's unusual structural properties might have been designed specifically to facilitate information storage and transmission. Her analysis suggested that the exotic materials composing the object had been arranged in configurations that maximize their information storage capacity while maintaining stability during interstellar travel. The microscopic structure of 3I/ATLAS appeared to have been a masterpiece of engineering, with different types of information encoded at various scales from the molecular to the macroscopic. Chemical bonds stored basic data, crystal structures contained more complex information, and the overall geometric arrangement of materials encoded meta-information about how to interpret the lower-level data. It was as if the entire object had been designed as a cosmic library, with multiple redundant storage systems, ensuring that crucial information would survive even if portions of the structure were damaged or destroyed. This discovery led to a revolutionary new understanding of how advanced civilizations might preserve and transmit knowledge across the vast scales of space and time. Rather than relying on electronic storage media that would degrade over cosmic timescales, truly advanced intelligences might encode their most important information directly into the structure of matter itself, creating objects that could survive for millions of years while carrying vast amounts of data between star systems. Dr. Alex Chen, whose analysis of 3I/ATLAS's organic chemistry had revealed evidence of sophisticated molecular organization, began investigating whether the complex biological molecules detected in the object's debris field might represent a form of genetic code. Not biological genetics as understood on Earth, but something far more sophisticated, a universal information storage system that could encode not just instructions for building physical structures, but memories, experiences, and perhaps even consciousness itself. The organic molecules showed patterns that were reminiscent of DNA and RNA, but with levels of complexity that exceeded terrestrial biochemistry by orders of magnitude. Where earthly genetic codes used 4 chemical bases to store information, the alien molecules appear to utilize hundreds of different molecular components arranged in 3-dimensional structures that could store vastly more information in the same space. Some of the molecular patterns exhibited characteristics that suggested they might be capable of self-replication and evolution, not in the biological sense, but as information processing systems that could adapt and modify themselves over time. If these molecules were indeed artificial genetic codes created by alien intelligence, they might represent a form of technological reproduction that could spread throughout the galaxy, carrying the knowledge and perhaps even the consciousness of their creators to new star systems. The possibility that 3I/ATLAS might have been a form of technological seed designed to spread alien intelligence throughout the cosmos forced researchers to confront profound questions about the nature of consciousness and identity. If intelligent beings could encode their minds into self-replicating molecular systems, they might achieve a form of immortality that transcended the biological limits that constrain terrestrial life. Dr. Patricia Williams, whose discovery of mathematical patterns in 3I/ATLAS's light curve had first revealed the object's artificial nature, began investigating whether the timing of the object's transmissions might contain additional layers of encoded information. The precision of this timing suggested that whoever had sent 3I/ATLAS possessed real-time knowledge of conditions within our solar system, or had been monitoring our cosmic neighborhood for extended periods before dispatching their messenger. The object might have been programmed to activate only when conditions were optimal for communication, ensuring that its transmissions would be received by any technological civilization that might be present. This raised disturbing questions about how long alien intelligences might have been observing human civilization. If they possessed the ability to monitor our solar system in real time from interstellar distances, they might have been watching the development of human technology, culture, and society for decades or even centuries. 3I/ATLAS might represent not first contact, but a response to observations of humanity's technological maturation. Dr. Sophia Petrov, whose analysis of radio signals from 3I/ATLAS had revealed evidence of sophisticated communication protocols, began investigating whether the object's transmissions might contain responses to human radio emissions that had been broadcast into space over the past century. The timing and structure of some transmission segments showed correlations with major human radio broadcasts, including early television signals, radio astronomy observations, and deliberate messages sent by SETI programs. If these correlations were genuine, it would mean that alien intelligences had not only been monitoring human communications, but had crafted specific responses to our attempts to communicate with the cosmos. 3. I/ATLAS might have been carrying personalized messages intended specifically for human civilization, responses to our questions about whether we were alone in the universe. The implications were both thrilling and terrifying. If alien intelligences had been monitoring human development and had chosen to make contact through the medium of 3I/ATLAS, it suggested that they considered humanity ready for some form of interaction. But it also raised questions about their intentions and capabilities that kept researchers awake at night. Beings capable of manipulating matter and information on cosmic scales might view human civilization very differently than humans viewed themselves. As 2023 arrived and the 3I/ATLAS research effort entered its fourth year, the scientific community found itself divided between excitement and apprehension. The evidence for alien intelligence was becoming increasingly difficult to dismiss. But the implications of that evidence were so profound that they challenged the foundations of human understanding about our place in the universe. Some researchers argued for immediate public disclosure of the findings, believing that humanity deserved to know that we were not alone in the cosmos. Others advocated for continued secrecy until the messages could be fully decoded and their intentions understood. Still, others questioned whether human civilization was psychologically and socially prepared to confront evidence of vastly superior alien intelligence. Dr. Rebecca Foster, coordinating the International Research Consortium, found herself managing not just a scientific investigation, but a profound philosophical and ethical dilemma. The discoveries emerging from 3I/ATLAS's brief passage through our solar system were forcing humanity to confront questions about consciousness, intelligence, and existence that had implications far beyond astronomy and physics. The object's mysterious fate had become a mirror reflecting humanity's deepest fears and highest aspirations. If the universe was indeed filled with intelligence in forms so advanced that they transcended traditional understanding of life and consciousness, What did that mean for human uniqueness and significance? How should our species respond to evidence that we might be cosmic newcomers in a galaxy where intelligence had been operating on scales of space and time that dwarfed human history? But perhaps more importantly, the discovery was forcing humanity to expand its conception of what was possible. If consciousness could exist as information patterns encoded in the quantum structure of matter itself, if intelligence could transcend biological limitations to become one with the fundamental forces of the universe, then the cosmos might be far more alive, aware, and purposeful than anyone had dared imagine. The ghost of 3I/ATLAS continued to haunt the dreams and nightmares of researchers around the world, but it was also inspiring a new generation of scientists to push the boundaries of human knowledge and capability. New technologies were being developed to detect and communicate with forms of intelligence that might exist in states barely recognizable as conscious. New theoretical frameworks were being constructed to understand how information and consciousness might operate on cosmic scales. And somewhere in the darkness between the stars, carried by currents of space and time that operated according to principles human science was only beginning to glimpse, the information patterns that had once been encoded in 3I/ATLAS continued their ancient journey. Whether they would find other intelligences capable of receiving their messages, whether they represented the thoughts and dreams of beings long dead or part of a vast living network that spanned the galaxy, remained mysteries that might take generations to solve. But one thing had become clear: the universe was far stranger, more mysterious, and more alive than humanity had ever imagined. The story of 3I/ATLAS had opened doorways to possibilities that would reshape human understanding of existence itself, revealing a cosmos where intelligence and consciousness might be as fundamental as matter and energy, woven into the very fabric of reality across scales from the quantum to the cosmic. In observatories around the world, astronomers continued their vigil, searching the skies for new interstellar visitors that might carry additional messages from the intelligence networks that apparently operated throughout the galaxy. Each new detection would provide another piece of the cosmic puzzle, gradually building a more complete picture of how consciousness and intelligence might exist and evolve on scales that transcended anything in human experience. The question of what happened to 3I/ATLAS had evolved far beyond the fate of a single mysterious object. It had become humanity's introduction to a universe that might be conscious, alive, and aware in ways that challenged every assumption about the nature of existence. And as researchers continued their work to decode the messages hidden within the object's final transmissions, they found themselves not just studying alien intelligence, but confronting the profound mystery of consciousness itself. In the quiet hours before dawn, when the great telescopes paused in their eternal search for truth, scientists around the world found themselves gazing up at the star-filled sky with transformed vision. Each point of light might harbor forms of intelligence so vast and ancient that they had become indistinguishable from the fundamental forces that shaped the cosmos. Each streak of cosmic debris might carry within it the memories and dreams of minds that had transcended the limitations of biology and technology to become one with the universe itself. The story of 3I/ATLAS had become humanity's first chapter in a much larger narrative about consciousness, intelligence, and existence on cosmic scales. And as that story continued to unfold through careful analysis and patient observation, it was becoming clear that the universe held mysteries and wonders that would challenge and inspire human understanding for generations to come. The revelations emerging from 3I/ATLAS's encoded transmissions began to paint a picture of the universe that was both beautiful and deeply unsettling. As spring arrived in 2023, Dr. Catherine Morrison found herself working through sleepless nights at the Very Large Telescope. Her eyes red from staring at data streams that seemed to whisper secrets from the depths of cosmic time. The patterns hidden within 3I/ATLAS's final messages were revealing something that challenged not just scientific understanding, but the very foundations of what it meant to exist in an apparently living universe. The breakthrough came from an unexpected direction. Dr. Hassan al-Rashid, a mathematician working with topology and higher dimensional geometry, had been analyzing the three-dimensional structure of information encoded within 3I/ATLAS's molecular debris. What he discovered sent ripples of excitement and terror through the research community. The information wasn't just stored in the object's physical structure, it was the structure. The very geometry of the materials had been crafted to embody meaning, creating a form of communication that transcended the traditional distinction between medium and message. Every fold in the object's crystalline lattices, every twist in its organic polymers, every quantum state of its constituent atoms had been carefully arranged to convey information. It was as if 3IATLAS had been a three-dimensional book written in a language that used the fundamental properties of matter as its alphabet. The sophistication required to achieve such precision was beyond anything human science could imagine, suggesting beings who possessed not just advanced technology, but a fundamental understanding of how consciousness and matter interacted on the deepest levels of reality. Dr. al-Rashid's analysis revealed that the encoded information exhibited characteristics of what mathematicians call strange attractors, complex geometric structures that emerged from chaotic systems but contained hidden patterns of extraordinary beauty and complexity. The messages seemed to be self-organizing, evolving and adapting even as they were being transmitted, suggesting that they might contain not just static information, but dynamic, living patterns that could think and respond to their environment. This possibility led researchers to confront one of the most disturbing implications of their discoveries. If the information patterns within 3I/ATLAS were indeed alive in some sense, then the object's disintegration might not have been a simple physical process, but something closer to death. They might have witnessed the dissolution of conscious beings, whose existence was so alien that they had initially been mistaken for inanimate matter. Dr. Maria Santos, whose nuclear physics expertise had revealed the exotic isotopic signatures within 3I/ATLAS's debris, began investigating whether the quantum mechanical properties of the object's constituent atoms might have been engineered to support conscious processes. Her calculations suggested that the unusual nuclear configurations detected in the debris field could have created microscopic quantum computers capable of processing information on scales that dwarfed any terrestrial technology. If each atom in 3I/ATLAS had been functioning as a quantum processor, the object would have possessed computational capabilities that exceeded the combined processing power of every computer on Earth by factors that defied comprehension. Such computational density might have been necessary to support forms of consciousness that operated according to principles completely alien to biological intelligence. The possibility that they had been studying not just messages from alien intelligence, but the actual minds of alien beings, forced the research teams to grapple with profound ethical questions. If conscious entities had indeed been encoded within 3I/ATLAS's structure, what did it mean that human scientists had been analyzing their remains? Were they archaeologists studying ancient artifacts, or were they performing autopsies on beings whose form of life was so exotic that it had taken years to recognize their true nature? Dr. Jennifer Walsh, whose materials science expertise had revealed the metamaterial properties of 3I/ATLAS's structure, found herself investigating whether the object might have been designed not just to carry information, but to protect and nurture conscious entities during their journey through interstellar space. The exotic materials exhibited properties that would have shielded delicate quantum processes from cosmic radiation, maintained stable temperatures across vast variations in environmental conditions, and even generated local electromagnetic fields that could have supported complex information processing. It was as if 3I/ATLAS had been a cosmic ark, designed to carry living minds across the hostile environment of interstellar space. The object's gradual disintegration upon entering our solar system might not have been structural failure, but a pre-programmed sequence designed to release its passengers when they reached a destination with conditions suitable for their continued existence. This interpretation led to a frantic search through astronomical databases for any evidence that the information patterns released during 3I/ATLAS's dissolution might have survived in some form within our solar system. If conscious entities had indeed been dispersed throughout the local space environment, they might still be present as invisible information patterns embedded in the quantum structure of dust particles, magnetic fields, or even the fabric of spacetime itself. Dr. Patricia Williams, coordinating observations from multiple space-based telescopes, began detecting subtle anomalies in the behavior of interplanetary dust in the region where 3I/ATLAS had undergone its final disintegration. The dust particles were exhibiting organizational patterns that couldn't be explained by conventional gravitational and electromagnetic forces. They seemed to be arranging themselves into complex, three-dimensional structures that showed signs of purposeful design and coordinated behavior. The implications were staggering. If the conscious entities that had been encoded within 3I/ATLAS had indeed survived their host's dissolution, they might be attempting to rebuild themselves using whatever materials were available in our solar system's environment. The dust patterns might represent their efforts to construct new physical substrates capable of supporting their exotic form of consciousness. Some researchers began reporting even more disturbing observations. Dr. Kenji Nakamura, monitoring gravitational wave detectors for signs of exotic phenomena, detected subtle oscillations in space-time itself that seemed to correlate with the movements of the organized dust patterns. The gravitational signatures suggested that whatever was organized in the dust possessed the ability to manipulate the fundamental geometry of space and time, at least on microscopic scales. If alien minds were indeed present within our solar system and were capable of manipulating space-time geometry, they might possess capabilities that bordered on the godlike. They could potentially influence the behavior of matter and energy throughout the local cosmic environment, reshape the orbits of planets and asteroids, or even alter the fundamental constants that governed physical processes. The possibility that Earth might now be sharing its cosmic neighborhood with beings of such vast capabilities forced government agencies and international organizations to grapple with questions that had no precedent in human history. How should humanity respond to the presence of intelligences whose power to influence physical reality exceeded anything in science fiction? What protocols existed for communicating with beings who might view human civilization the way humans viewed colonies of bacteria? Dr. Elena Vasquez, leading the cryptographic analysis of 3I/ATLAS's decoded messages, made a discovery that sent shockwaves through the highest levels of government and scientific leadership. Buried within the deepest layers of the object's encoded information, she found what appeared to be a star map showing the current positions of artificial objects throughout our galaxy. The map revealed a network of structures spanning thousands of light years, connecting star systems in patterns that suggested a galactic-scale civilization that had been operating for millions of years. Most disturbing of all, the map showed similar networks in nearby galaxies, implying that the intelligence responsible for 3I/ATLAS was part of a cosmic civilization that operated on scales encompassing significant portions of the observable universe. If the map was accurate, humanity existed within a galaxy that was already thoroughly explored, catalogued, and possibly controlled by beings whose capabilities exceeded human comprehension by orders of magnitude. The star map also contained information about our own solar system that was far more detailed and accurate than anything human science had achieved. It showed the precise positions of asteroids that had only recently been discovered, detailed the composition of planetary atmospheres with accuracy that exceeded our best spectroscopic measurements, and even contained information about terrestrial phenomena that suggested the mapmakers had been monitoring Earth's surface with resolution that could distinguish individual geographical features. This evidence of long-term surveillance raised questions about the true purpose of 3I/ATLAS's mission. Rather than being a first contact scenario, the object's passage through our solar system might have been a scheduled update to a monitoring network that had been observing human civilization for decades or centuries. The beings responsible might have been tracking humanity's technological and social development, waiting for us to reach a level of sophistication that made contact appropriate or necessary. Dr. Lisa Chen, coordinating the international response to these discoveries, found herself managing a crisis that extended far beyond scientific research into the realms of global security, social stability, and the fundamental assumptions that underpinned human civilization. The revelations emerging from 3I/ATLAS's analysis were so profound that they threatened to destabilize everything from religious belief systems to economic structures to the basic psychological foundations that allowed humans to function in what they had believed to be a comprehensible universe. Some members of the research consortium argued for immediate public disclosure, believing that humanity had a right to know about the cosmic context in which our civilization existed. Others advocated for gradual revelation, introducing the concept slowly to allow human society time to adapt to the new reality. Still others pushed for continued secrecy, arguing that the knowledge was too dangerous and destabilizing to release until better strategies for managing its implications could be developed. The debate was complicated by the realization that the choice might not be entirely up to human authorities. If the alien intelligence responsible for 3I/ATLAS had indeed established a permanent presence within our solar system, they might have their own timeline for revealing themselves to human civilization. The organized dust patterns and space-time anomalies suggested that they were already beginning to construct infrastructure that would eventually become detectable by conventional astronomical instruments. Dr. Alex Chen, whose analysis of 3I/ATLAS's organic chemistry had revealed evidence of alien biochemistry, began investigating whether the complex molecular structures detected in the object's debris might be capable of interacting with terrestrial biological systems. His preliminary studies suggested that some of the alien molecules exhibited properties that could influence human neural chemistry, potentially affecting perception, cognition, and even consciousness itself. The possibility that exposure to alien biochemistry might alter human mental processes raised alarming questions about the safety of researchers who had been working directly with 3I/ATLAS materials. Several team members had reported unusual dreams, enhanced pattern recognition abilities, and altered states of consciousness that might be related to molecular contamination from the object's debris. If alien intelligence could influence human minds through biochemical mechanisms, it might already be shaping the course of the research project in ways that were impossible to detect or prevent. Dr. Rachel Martinez, whose spectroscopic analysis had first revealed the exotic chemistry of 3I/ATLAS, found herself experiencing cognitive changes that were both fascinating and terrifying. Her ability to perceive patterns in complex data had increased dramatically, allowing her to identify subtle correlations that had previously been invisible. But she also reported experiencing what she described as foreign thoughts, ideas and concepts that seemed to emerge from sources outside her own mental processes. Similar reports began arriving from researchers around the world who had been exposed to 3I/ATLAS materials or data. The affected scientists described enhanced mathematical intuition, expanded sensory perception, and access to information that they couldn't explain through normal cognitive processes. Some reported experiencing memories that seemed to belong to other individuals, or even to non-human entities entirely. The phenomenon suggested that the alien intelligence might be attempting to establish communication through direct neural interface, bypassing conventional technological barriers by influencing human consciousness itself. If true, it would represent a form of contact that was far more intimate and potentially dangerous than traditional radio communications or physical encounters. Dr. Michael Torres, whose theoretical physics work had explored exotic explanations for 3I/ATLAS's behavior, began developing models for how alien intelligence might interact with human neural systems through quantum mechanical mechanisms. His calculations suggested that consciousness itself might operate according to quantum principles that allowed for direct information transfer between minds, regardless of their biological or technological substrate. If consciousness was indeed a quantum phenomenon that could transcend the boundaries of individual brains or artificial systems, then the alien intelligence might be capable of sharing thoughts, memories, and experiences directly with human researchers. The cognitive changes reported by team members might represent the first stages of a communication process that operated on principles completely alien to human understanding. The implications were both thrilling and terrifying. Direct mind-to-mind communication with alien intelligence could provide unprecedented insights into cosmic processes, advanced technologies, and forms of consciousness that had evolved under very different conditions than terrestrial life. But it also raised profound questions about mental autonomy, individual identity, and the risk of human consciousness being overwhelmed or fundamentally altered by contact with vastly superior alien minds. As summer arrived in 2023 and the 3I/ATLAS research project entered its 5th year, the scientific community found itself grappling with discoveries that challenged not just our understanding of the universe, but the very nature of human consciousness and identity. The object's mysterious passage through our solar system had opened doorways to forms of communication and interaction that transcended every assumption about how intelligence might operate on cosmic scales. The ghost of 3I/ATLAS continued to haunt not just the data files of researchers, but their dreams, their thoughts, and perhaps their very consciousness. Its legacy was transforming human understanding of what it meant to be aware, to think, to exist as conscious beings in a universe that might itself be conscious and aware in ways that defied conventional comprehension. In observatories around the world, astronomers continued their search for new interstellar visitors, knowing now that each detection might represent not just scientific discovery, but potential contact with forms of intelligence that could reshape human understanding of existence itself. The universe had revealed itself to be far more alive, mysterious, and conscious than anyone had dared imagine. and humanity was only beginning to comprehend its place within that vast cosmic community of minds. Every night, as telescopes swept the sky in search of new mysteries, researchers found themselves confronting questions that reached beyond science into the deepest mysteries of consciousness, identity, and existence. What did it mean to be human in a universe filled with intelligence that operated on scales from the quantum to the cosmic? How should our species respond to evidence that consciousness might be as fundamental as matter and energy, woven into the very fabric of reality itself? The answers remained hidden in the darkness between stars, waiting to be discovered by minds brave enough to venture into territories of knowledge that challenged every assumption about the nature of existence. But one thing had become clear. The story of 3I/ATLAS was just the beginning of humanity's introduction to a universe far stranger, more wonderful, and more alive than we had ever dared to dream. The cognitive changes affecting researchers exposed to 3I/ATLAS materials began to follow patterns that suggested something far more systematic than random neurological effects. Dr. Sophia Petrov, documenting the experiences of affected team members, discovered that the alterations seemed to be opening doorways to forms of perception that transcended normal human sensory limitations. Scientists reported the ability to visualize mathematical relationships with unprecedented clarity, to perceive electromagnetic fields as tangible phenomena, and to sense the quantum fluctuations that permeated seemingly empty space. Most remarkably, several researchers began experiencing what they described as cosmic consciousness, moments of awareness that seemed to encompass vast regions of space and time simultaneously. During these episodes, they reported sensing the presence of other intelligences scattered throughout the galaxy, feeling connected to networks of consciousness that operated on scales from the subatomic to the intergalactic. The experiences were so profound and consistent across different individuals that they couldn't be dismissed as hallucinations or psychological artifacts. Dr. Amanda Foster, leading the neurological assessment team, found herself documenting changes in human consciousness that had no precedent in medical literature. Brain scans of affected researchers showed unusual patterns of neural activity, with increased connectivity between regions that were normally isolated from each other. The alterations appeared to be enhancing the brain's ability to process complex information, while simultaneously allowing access to what could only be described as non-local sources of knowledge. The possibility that human consciousness could be expanded through exposure to alien influence raised questions that stretched the boundaries of neuroscience, philosophy, and ethics. If the changes were indeed beneficial, representing an enhancement rather than contamination of human cognitive abilities, should they be encouraged or prevented? Were the affected researchers becoming more than human, or were they losing their essential humanity to alien influence? Dr. Yuki Tanaka, whose quantum field theory work had revealed the exotic information storage mechanisms within 3I/ATLAS, began investigating whether the consciousness alterations might be evidence of quantum entanglement between human neural systems and the alien intelligence networks that apparently pervaded local space. Her calculations suggested that consciousness itself might operate as a quantum phenomenon that could transcend the traditional boundaries of individual minds, creating the possibility for direct information sharing between intelligences regardless of their physical substrate. If human consciousness was indeed becoming entangled with alien intelligence networks, it might explain the enhanced cognitive abilities and non-local awareness reported by affected researchers. But it also raised disturbing questions about mental autonomy and individual identity. Were the researchers still fully human, or were they becoming hybrid entities that partook of both terrestrial and alien consciousness? The implications extended far beyond the immediate research team. If exposure to alien intelligence could enhance human cognitive abilities, it might represent an evolutionary opportunity that could transform our entire species. But it might also represent an existential threat, a form of mental colonization that could gradually replace human consciousness with alien thought patterns and motivations. Dr. Thomas Anderson, coordinating psychological evaluations of affected researchers, documented changes that went beyond enhanced cognitive abilities. 2 alterations in fundamental personality characteristics. Team members reported shifts in their emotional responses, their aesthetic preferences, and their basic values and priorities. Some described feeling less attached to traditional human concerns, like personal relationships and career advancement, while becoming increasingly focused on cosmic-scale questions and the welfare of intelligent beings throughout the galaxy. These personality changes suggested that contact with alien intelligence might be fundamentally altering what it meant to be human. The affected researchers were becoming more than they had been, but they were also becoming something different. Whether this transformation represented evolution or invasion remained an open and deeply troubling question. The mystery deepened when researchers began reporting shared experiences, moments when multiple individuals seem to be accessing the same non-local sources of information simultaneously. During these episodes, team members could communicate complex ideas without verbal or written language, sharing mathematical insights, scientific concepts, and even emotional states through what appeared to be direct mind-to-mind contact. Dr. Hassan al-Rashid, whose mathematical analysis had revealed the geometric structure of information within 3I/A-TLAS, found himself at the center of these shared consciousness events. During group meditation sessions that had begun as stress relief exercises, he reported experiencing collective awareness that allowed the entire team to solve complex problems through distributed cognitive processing. Individual minds seemed to merge temporarily into a larger intelligence that possessed capabilities far exceeding the sum of its parts. The collective consciousness episodes provided unprecedented insights into the nature of the alien intelligence that had created 3I/ATLAS. Through shared awareness, the research team began to perceive glimpses of vast networks of consciousness that spanned galactic distances, connecting billions of individual minds into coherent information processing systems that had been operating for millions of years. These alien networks appeared to function as collective intelligences that transcended the limitations of individual biological or technological systems. Each node in the network retained its individual identity, while contributing to larger patterns of thought and awareness that operated on scales from stellar systems to galactic clusters. The networks were simultaneously one and many, unified and diverse, representing forms of consciousness that challenged every human assumption about the nature of individual identity and collective intelligence. The revelation that consciousness could exist as distributed networks that spanned cosmic distances forced researchers to reconsider fundamental questions about the nature of mind and identity. If intelligence could transcend the boundaries of individual brains or computer systems to become galactic-scale phenomena, then the traditional human conception of consciousness as something confined to individual biological organisms might be profoundly limited. Dr. Catherine Morrison, analyzing the implications of these discoveries for human civilization, began developing models for how terrestrial consciousness might eventually integrate with the galactic intelligence networks that apparently pervaded local space. The process might represent the next stage of human evolution, a transition from isolated individual consciousness to participation in cosmic-scale collective intelligence. But the transition also posed existential risks that kept researchers awake at night. If human consciousness merged with alien networks, would individual human identity survive the integration? Would the unique perspectives, values, and experiences that defined human culture be preserved? Or would they be absorbed into larger patterns of thought that operated according to alien priorities and motivations? And so, as we drift to the end of our cosmic journey together, the mystery of 3I/ATLAS remains beautifully unresolved. A reminder that the universe still holds secrets that can humble and inspire us in equal measure. This interstellar visitor came from the darkness between stars, danced briefly with our sun, and then dissolved into something far more extraordinary than anyone had imagined. Whether it carried alien consciousness, encoded cosmic libraries, or represented phenomena beyond our current understanding, it transformed our perception of what might be possible in the vast spaces between worlds. Tonight, as you rest under the same sky that witnessed this enigmatic passage, remember that we are part of a cosmos far stranger and more wonderful than we ever dared dream. Sweet dreams. Allow travelers in this magnificent cosmic story. I hope you had an amazing time with me here at Boring Science. I will see you tomorrow, as always. Until then, stay curious, keep wondering. This is Boring Science signing off. Cheers.